Hi, welcome to a very interesting paper on design science. Design science is a type of um, design method or a type of method used in the field of information systems, and for some, it is still very confusing of what is needed because most reviewers are not familiar with this method, and it can really get difficult reviewing papers on this niche. But today, let's talk about a paper by Ken Peffers et al. And Ken actually wrote this paper with a bunch of very influential people in the figure in the subject, people like Ture, Tunanin, and Marcus Rothenberg. And this paper is one of the foundational papers around design science. So today, without further ado, let's talk about it. So today, we are going to be exploring the quest of relevance of design science in information systems research. This paper, like I said, is published in the Journal of Management Information Systems in 20 is in 2007, and this paper is a cornerstone of the field. So let's go to the next second page. I want this to be as interactive as possible because I'm also learning as I explain. So maybe I'll make a few mistakes, but I will try to correct myself as fast as possible. So let's begin with the core problem. I would love to call this the relevance gap. Information system is inherently an applied discipline, and our mandate is to solve problem at the messy, complex, and intersection of technology and the organization. That's what information system is about. However, for a long time, we have actually borrowed our dominant research paradigms from natural and social sciences. And these paradigms are excellent for describing reality. They are excellent for explaining why things happen the way they do, but they often fall short of building solutions. So we see ourselves always describing things and explaining things because this paradigm is largely borrowed from the social science and the natural science, but we don't really build much things. So this actually created a disconnect. It's created a disconnect because why academics we are busy theorizing, practitioners we are facing real world challenges that our research wasn't addressing, and I think this is a big issue. So consequently, practical field like software engineering began to dominate the creation of applications and solutions because they explicitly value design. Because if you're in computer science, it's all about building things, right? Building something. Why IS research risks actually becoming purely observational, and this is not what we want. We don't want IS to be just to observe and explain. We want to be able to build things to like the computer science people because we want to build practical solution to problems we face in the business world. So whereas we see natural sciences and social sciences try to understand reality, design science attempts to create things that serve human purpose. So it's more like science of the artificial. To create artificial things, we're not trying to understand things. We are trying to create why we try to create things that are useful. So on this slide, we see design science as a paradigm of creating the future, and we see the bridge. What is design science? So to formally define design science is the science that creates and evaluates IT artifacts intended to use to solve identified organizational problems. Finish. The whole idea is to create and evaluate IT artifacts which is intended to solve identified organizational problems. It is not about just hacking or coding. It involves a rigorous process and a rigorous process to this designing the artifact. So you have to the rigorous process means that you have to design these artifacts, evaluate them, and communicate the contribution from these artifacts. So when we say artifact, we mean four specific things. So there are like four specific contributions your artifact can make. Like I said, the artificial things you build. One, so it's not just about building the software or building a program. No, it has to make a relevant contribution. And construct is one of them. So these are the vocabulary and symbols you use. I'm gonna kind of explain this probably on the last slide. And the models. So the models are like the abstraction and representation, how the construct, how the vocabulary you come up with are connected together. So when you want to design something, you're coming up with vocabularies, you know, to 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 define your design. Like there's a particular one I was involved in. We designed a compassionate respondent system. That is a construct. So the model is how this construct actually work together. Then the method is the method, the algorithm, the practice, the method you use. Then the instantiation is the actual implemented systems or prototype. When you instantiate, it means that maybe the actual working project. So despite being introduced in the early 90s, this approach was slowly to be adopted. It wasn't an easy adoption for people or scientists. Why? Because we lacked a common framework. The field lacked a consensus, a common framework. So without a shared mental model or a template, researchers didn't understand how to present their work, and mistook rigorous design. Um, reviewers mistook rigorous design science for mere consulting. So you know, like routine design. So it's then it was a thin line between design science and creating routine design. Routine design is like creating an app, creating a website. But design science is not routine design. It's all about coming up with something novel. So reviewers do not understand the difference between, are you a consultant or a design science researcher? So there was a lot of confusions there. So looking at the slide, so the bridge is the design science research methodology. So this paper introduced the methodology, a blueprint for rigorous and relevant research. To fix the relevance gap, Peffers and his colleague developed this methodology to serve as a blueprint for rigorous research. Um, this methodology achieves three crucial goals. First, it provides a nominal process that's like a clear step by step roadmap for doing the work. Second, it builds on prior literature. It doesn't reinvent the wheel. It tries to integrate principles from engineering, computer science, and earlier IS thinker like Hebner. Oh, Hebner is such a great guy. I took pictures with him during the ISIS conference. And third, it offers a mental model. This gives us a template, actually. So just as we have a standard structure, just as we have a standard structure for, give me a second. Am I really recording this? Okay, yes, I'm recording this. So just as we have a standard structure for empirical paper, design science research methodologies gives us a structure for presenting and evaluating design research. And this legitimacy is what allows design work to stand on shoulder to shoulder with traditional theory building. So here the design science process model. So this is a six-step flow chart. Here's the core of the method, the design science process model. It consists of, first of all, you have the problem identification and motivation, and you have to find the problem. Two, you have to define objective for a solution. Three, you have to design and develop. Four, you have to demonstrate. Five, you have to evaluate. Six, you have to communicate. Now, this process provides a structural flow from initial conception, when you find the problem, and all the way to communicating the result. While it looks sequential here, we still we will we will see that research can actually start at a different point. I don't know if you understand me. Why we are seeing a sequential method here, but necessarily you don't need to follow it from a sequential method. The research can start at any point. It can start with the design and development. It can start with the demonstration. So that I think you should take note of that. So here the 6 activities in details. And let me get my face away from here. Sorry if that's a problem. Activity 1, problem identification. You must define the specific research problem and crucially justify why a solution is valuable. This motivation is what hooks your audience. Like I said, you have to have a specific research problem. 2, define objective of a solution. Now, based on your problem, what does the solution need to do? This objective can be quantitative, like reduce processing time by 50%, or qualitative, like enable new type of interaction. So whatever the objective of the solution, you should know whether it's quantitative or qualitative. Activity 3, design and development. This is the core build phase. You create the artifact, whether it is a model, a method, or an instantiation, or a construct. You determine its functionality and architecture. That is next. Then the activity 4, demonstration. You have to demonstrate. You must provide the artifact. You must prove that the artifact works by using it to solve an instance of the problem. This could be simulation, a case study, a proof of concept. So you have to demonstrate. Number 5, you have to evaluate. This goes deeper than demonstration. You must observe, measure how well the artifact supports the solution by comparing actual results, and by comparing the actual results against the objective you defined in step 2. And finally, activity step 3, communication. You must share the problem, the artifact, and its rigorous evaluation with the academic and professional community. Define objective of the solution. 2. Okay. Design. Should observe and measure how well the artifact supports solution. Okay. So, oh god. Okay. So slide 7. Check my phone. So slide 7. One of the most the research journey is not always linear. Yeah. One of the most powerful insights from this paper, Peffers et al., is that research journey is not always linear. You don't always have to start at step 1, like I said. The framework identifies 4 distinct entry points. We see the problem-centered initiation. That's if you want to start with the problem. This is a classical route, starting at activity 1, driven by an observed problem or a gap in literature. That's if you want to start with the problem. Then the objective-centered initiation. This is the activity 2. Yeah, activity 2 over here, which is this starts at this often triggers by an industry need. We know what we need to achieve, and even if the specific problem isn't fully articulated yet, so you are coming from the angle of an objective centered initiation, which is often triggered by an industry need. We know what we need to achieve, even if the specific problem isn't fully articulated yet. Then number 3 is the design and development. If you're coming from the design and development angle, and this starts with activity 3, the problem. This happens when you have an existing artifact, perhaps from another field, that you want to adopt and formally apply to a new domain. Either if you want to start from activity 3, begin with an existing artifact that you need to formally apply to a new problem domain. This can actually work. Then the client context initiation. That's activity 4. This is common in consulting. You observe a practical solution working in the wide, and you work backwards to apply rigor and formalize that research. That's also for fun. Like, you see something working, you're like, okay, there's a word for it. It's called reverse engineer it, and apply rigor and formalize it as a research, something that is already working. It's not like seeing a word anymore and you're trying to claim it. So I'm going to slide 8. The design science in practice, a framework of success. So to prove that this methodology works, the author applied it retroactively to 4 published IS research. This case study illustrates the framework supports different research journey. So 4 of them is a catch data warehouse, a problem-centered study on health assessment, a software reuse model, an objective-centered study creating new metrics, SIP-based IP telephony, a design-centered study extending internet protocol, a critical success chain method, a client-initiated study generating ideas for mobile app. So let's look at how these map the framework. That's 9. And so in the problem-centered case, the catch data warehouse, researchers started with a clear problem. Health data gathering was too labor intensive, and their artifact was a data warehouse that automated this process. So in the objective-centered software reuse case, the goal was to explicitly define the goal was explicitly defined first, to create a formal reuse rate measure for a specific enterprise environment. So the contribution was a generic metric that could be customized. In the design centered ISP case, they started with an existing standard ISP to voice, and like I said, you can start with the design centered, and designed an extension for a video. The artifact was a working Java application. In the client initiated case, a company called Digia needed a needed uh, mobile app mobile app ideas. The researcher used the client the researcher used this client need to demonstrate a new method called a critical success chain. So they kind of like, found something that already existed. So mm, so like a company, like I said, the company called Diga needed a mobile app design, and the researcher used this client need to demonstrate a new planning method called critical success chain. So this they're using a client need to come up with a method, a research method. So like I said this in like a few minutes ago. So all four resulted in high quality publication. So you as a researcher should ask yourself, where do I start? Should I use a problem centered approach or a design centered approach, or should I use a client initiated approach? The client initiated if you're like maybe working in a consulting area, or objective centered, or whatever. Like right now, I'm trying to get a lot of idea. Probably use something around objective centered. So let me even go back to the slide here. Let's say I want to use an objective centered initiation. I can triggered by a known industry or research need that requires an artifact. Yeah, you know, let me just go ahead because I don't waste time. This is not the time to brainstorm a new research. I'm just doing a video to explain the concepts. So so here a closer look at the catcher data warehouse journey. So let's zoom in one of the specific examples, the problem. Here we see the problem was that public health policy was hindered by data processing, was hindered because data gathering was slow and expensive. So the objective was they needed to develop a data warehouse to provide automated, cost-effective support for this health assessment. So design and development, they built the artifact using a star schema design and quality assurance method. So the demonstration, they didn't just write about it, they adapted it for production use in Miami Dade County and even used it for biometric surveillance. So evaluation, they verified the system was flexible and effective in the field. Communication, finally they published their work in a decision support system and IEEE proceedings. So you see, design science is not about crunching numbers. It's all about solving real problems, and there's several approaches to it. And so, if you want to do it, you have to find the approach that best serves you. Do you want to start with a problem, or do you want to start with an objective, or do you want to? So, whatever method resonates with you, wherever you want to start is okay. So, this is a typical example. So let's go to slide 11. So ultimately, design science provides the information systems discipline with a complete and validated research paradigm. It is consistent with prior literature, mapping clearly to earlier models like non-maker, Walls, and Hefner. It provides a nominal process as proven by the effectiveness of the four case studies. And it provides a mental model, and this is perhaps the greatest contribution. It gives us a template for presentation. It moves us beyond making ad hoc argument for why our design work is a valid research, and it establishes a common language for others, reviewers, and editors all can share. So to go to 3, which is the final slide. So, empowering researchers to build the future. So, this design science guided by design science methodology, which this paper wants to introduce, fundamentally shifts the role of the IS researcher. We no longer just observe, we no longer just count things, because trust me, sometimes I just sit and say, we are supposed to be a technical field, and all we just do is to just observe, you know, observe what is naturally existing, observe how human beings are behaving. It can get tiring sometimes. So this methodology closes the relevance gap by equipping us with to not only analyze the world but actively create novel artifacts that solves meaningful problem. So we conclude, members. So we conclude. Remember the distinction. Whereas natural science and social science try to understand reality, design science attempts to create things to serve human purpose. And design science research is your blueprint for that creation. So, personal note, um, this is one of the reasons I love this research stream and paradigm. Yes, it is, and I think I have to keep looking for ideas and build my research stream around a particular problem. And on a final note, I think I didn't talk about kernel theories, right? Probably because it wasn't really emphasized in this paper, but subsequently, that other paper that I think the Hefner et al. Talked about kernel theory, but the Peffer et al. 2027 doesn't. Yeah, so just watch out for more videos. So let me look for my ending button. I think the video ends here.